Welcome everyone to quick Linux kernel development live stream. Here the only constant is change and regressions, and like other news sites say, what do those open source developers fix every day? Everything just works. Yeah, everything just works because we keep fixing everything every day. Case in point, for a while I knew the PowerPC, especially 64-bit kernel, was at times failing seemingly randomly, but usually with size optimization in this way here that I present you here on the screen, which is mod post error, quite some, restore, FPR, save, GPR, and stuff missing symbols, undefined there. 56 unresolved symbols. Warnings because there were too many. Those functions, of course, I knew, but for you looking those up, those are part of the PowerPC ABI here. Various, they call it save and restore services here from the 64-bit PowerPC ELF application binary interface supplement 1.9. Certainly other variants. Systems must provide 3 sets of routines which may be implemented at multiple entry points routines or as individual routines. They must adhere to the following rules. Each save GPR0 _n routine saves the general registers from Rn to 31 inclusive, in contrast to exclusive. Each routine also saves LR. When the routine is called, LMR1 must point to the start of a general per register save area, and R0 must contain the value of LR on function entry. The rest GPR0 _n routines restore the general purpose registers from Rn to R31 and then return to the caller. When the routine is called, R1 must point to the start of the general register save area. Here is a simple implementation of save GPR0 _n and rest GPR0n. So what this does, as you see here, this is just creating some global symbols, reusing all of this. So basically restore 0, 14 and up, so restoring from 14. So basically this is not a return, that is not only a sample but most likely also the most efficient implementation. Thanks for IBM and Foundation members for providing that. So this is of course used if functions need to restore a couple of or a vast amount of registers, and so the reason obviously why this is occurring for some of our builds is especially for size optimization. When the compiler, usually with size optimization, decides we save and restore so much instead of individually saving and loading some registers, let's just call into a library routine for those, right? Makes sense instead of, like, if it's more like 4 or 5 instructions, and obviously calling into there, especially for size optimization, certainly saves quite some instructions all over the place. The reason, today I thought, like the usual thing, we built a YouTube channel, we finally have some income to finance all the open source work here, thanks to your share, like, subscribe, Patreon. I thought I'd quickly fix this, and to my surprise the fix was super easy. I wonder why. Basically it kind of sort of just works. So obviously, how do you engage that? How do you approach that? I usually just grab very similar things already occur in the Linux kernel, right? To my surprise, this is in moddep here. They had some special handling. I patched that already. So turns out in scripts mod post is actually handling for that, rest whatever here, for PowerPC and PowerPC 64. And so a huge amount of those. So basically, I think that you will see in the diff. So basically, I just added that. I was prepared, so what the next step I would have done is I would have copy and pasted this sample implementation here that looks good enough and probably not really much more to optimize here. I wanted to copy and paste this to the kernel, but to my surprise, adding this here to the mod post Linux kernel module handling here for basically ignoring those here, basically allowing those special register functions linked on all modules during final link of KO, aka kernel object. So as you see, they had already rest GPR0 to stuff, just not GPR1 to stuff, as well as this restore and save floating point registers, right? The reason that even occurs, to give you a little bit more background that you playing along at home also learn something. The reason this occurs here with AMD GPU most of the time is that usually, I said this a couple of times before, especially for RISC-V, right? Remember when we were the first over 2 years ago? It is only getting now into the upstream Linux kernel. Remember when we were running AMD RDNA2, AMD GPU on RISC-V, right? One of my most viral videos that made it to various news sites, and only now makes it to upstream Linux kernel because YOLO, other developers usually don't care as much. And I said it there already that usually the Linux kernel designers like Linus Torvalds made the decision, like many kernels 30 years ago, not to allow floating point in the Linux kernel, right? So that is to avoid exactly context saving, right? So the Linux kernel runs without floating point, so that for context switching between user space programs like Bash or Firefox or GCC, anything normal programs run, the Linux kernel, similar to Windows or other BSD kernels, does not need to waste CPU and memory cache cycles to save and restore floating point registers. Only some points in the Linux kernel actually have special sequences. So if you want to use floating point in the Linux kernel, you actually need to call enable floating point so that the registers are actually saved and restored, because obviously the Linux kernel cannot clobber randomly floating point registers that are used by Firefox and stuff. So the reason that AMD GPUs were using that, they're actually using that in their mode setting. And recently, actually, people worked on that. To actually remove quite some floating point math. From what I've seen, they use floating point math to compute their mode setting of various previously timings of sync timings, front and back port and stuff, and vertical, horizontal sync and stuff, and then some PLLs. Usually for these timings you will need floating point math, most likely more for some PLLs. Of course, nowadays stuff is HDMI, so what precisely in their complex Windows inherited code they do there, whatever. And to my surprise, this was enough, right? So yeah, that's the reason why this mostly shows in AMD GPU or theoretically other vector math functions like RAID and stuff. So all the RAID and other crypto code would need to call enable FP. We can quickly check. I think enable FPU here, for example. I think so most architectures don't even have that. Only x86 PowerPC and since recently ARM and my RISC-V patch have that, allegedly also super edge of all architectures. Others don't have that. Whatever that, maybe that is for user space switching. Yeah. The crazy thing is that that is enough, right? I don't quite instantly see where this code is coming from now. Similar code, like if you were wondering where is it implemented, that is in PowerPC 0 they had here. So yeah, that is somewhere there. But the actual code was in maybe lib and then CRT save res. So that code lives here. I don't instantly see. So this is how this looks, right? For save GPR 14, 15, you get the idea, right? Storing and loading that. They don't have the code for what we were looking for. So basically that was save GPR1 and floating point registers. But to my surprise, it somehow works. I have no idea how it works, but it does work, I believe. Because if we go in here into GPU DRM AMD GPU, the symbols are there. I mean, it obviously linked and mod posted. Hello? Oh, best without typo. And if we object dump that, as I've done already previously, if we are in the right directory for that, do I still have that? No, I don't. Okay, rest, whatever. You see it is in there, including the variant that previously errored out, right? So here, for example, save GPR. So I don't know if they link with libgcc or how they got in there. So, I mean, what we actually could theoretically do. So basically, it appears to work. I probably next need to install a AMD RDNA 2 into my Open Power 8 server and give it a run. Share, like, and subscribe for that fun. So that is, for me, good enough. It looks like it should work. And I wonder that the recurring theme, why has nobody between IBM and Red Hat done that for years? Because basically that annoys me for years that I get random kernel breakage because we smart optimize most stuff for size except high performance code, because obviously the mode setting code, our T2 invented smart optimization, like smart profile database of everything is size optimized because small code, never run code, not clobbering caches and stuff, and only high performance stuff is actually optimized. So that actually annoyed me quite a bit. Also, of course, if you do embedded stuff, like, embedded stuff, SPC stuff, obviously most people want also size optimization, for example. And this is the kind of stuff like, why does this not just work for years? But obviously, thanks to you all subscribing and Patreon, we can finally, like, with everything, nearly everything else working in T2, including our PS3 and SGI02, we can finally fix every bug the Linux kernel developers throw our way. So yeah, that looks like it should work. We can, as a last thing, quickly try to see what precisely they link into, because I'm a little bit wondering that this actually was that simple. Because again, I expected to patch that in there, but somehow it works for some strange reason, which makes me wonder even more why some IBM people have never done that before, but somehow we are here to fix everything. We deleted that, so we need to rebuild the modules, and with verbose, I always forget, is it this, is it the other? Maybe verbose works, maybe V works. Maybe clearing Q works. Every build system, their own fun stuff. Let's see what we get for AMD GPU here. Apparently not yet, not really sure why. Here we get something. So they linked that with LD, no executable stack, no more RX, save, restore. Here, save. Maybe this is doing that. Okay, we found something new. That probably is how this, which was it, GCC, right? Or was it, no, it was actually LD. Interesting. So maybe this comes from libgcc then, would be plausible. Let's see what happens if we, these two options control whether PowerPC 64 LD automatically provides out-of-line register save and restore function used by OS code. The default is to provide any such referenced functions for normal final link and to not do so for relocatable links. Okay, fine. It's coming from there, most likely from libgcc. We could further debug that, but it's kind of also good enough, libgcc or other support functions. Anyway, we fixed this. Amazing. That is obviously as amazing as other YouTubers getting their Commodore 64 or PDP-11 restored. So fix file diff that, and then we call it another successful day here in our open source workshop studio. Fix file diff, let's save that to hot. And then obviously I need to spend another half an hour to write a nice cover letter to send in for IBM engineers to review for inclusion in Linus Torvalds amazing, outstanding Linux kernel. So hotfix, PowerPC 64, hello, 64, maybe I need a new keyboard, not LE, 64 OS, do we call this further of, oh, you know what, we can simply call it that, save restore function dot patch. And as we want to be a good example. What I always suggest others to do and prefer by myself is to include the actual failure in the log, right, in the patch, so that if I look into that in weeks or months to come, or need to send it in like for review by IBM, then obviously it is nice to have that at hand. So package Linux hotfix PowerPC 64, save restore functions. Here another nice to have patch for our PS3 fun svn add and rebuild for you for the next T2 ISO to play along at home and have the highest possible performance. Linux kernel also for your PS3 and Apple G5. Question there. Hi, just curious, is there still some infrastructure that runs on PowerPC architecture like legacy archiving systems or banking? Well, you will be surprised that IBM still sells state-of-the-art systems, right? So you get latest, and they obviously still develop new systems. So IBM, not even sure if IBM Power 10 is probably the latest. So they sell extremely high performance systems, right? It's not like legacy systems. You can, like even Google allegedly has open power systems in their data centers, right? So Power 10 is a superscalar, multi-threaded, multi-core microarchitecture based on the open source Power ISA and announced August 2020 at the Hot Chips conference. Systems with Power 10 CPUs generally available from September 2021 in the IBM Power 10 Enterprise E1080 server. Processor is designed to have 15 cores available, but a spare core will be included during manufacturing to cost effectively allow for yield issues. And there is even Power 11 coming up next, right? So that is not legacy, that is latest and greatest high performance, reliable, and so on things. I'm pretty sure Power 11 was already IBM hints at Power 11, hopefully will fix Power 10s, whatever that nitpicking is there on something. So there will most likely be Power 11 future patches for somewhere enablement. There would be the source of found on GCC patches. This patch is preliminary support for potential new features. PowerPC 6 into the current Power 10 MMA architecture. The current MMA subsystem for Power 10, there are 8 512-bit accumulator registers. These accumulators are each tied to a set of 4 FPR floating point registers, and so on and so forth, are then extended to a whopping 1024 bits, and new instructions will be added to deal with all 1024 bits. And so on and so forth for the either 3.1 documentation using the MMA subsystem. So that's basically it. Stuff is building. Our PS3 is running at higher performance than ever. I slightly wonder, we could quickly check. I had some at least Firefox patches, which obviously don't forget to share, like, and subscribe, because we also have Firefox to fix to actually not segmentation fault on PowerPC, including our precious PS3 collections. That would be Firefox. And do we have here some ELF version 2? Okay, we are also best with... Because once upon a time I patched something. There was some back and forth here with this ELF ABI. Okay, that is 32-bit. Okay, wherever... Maybe that was already... Maybe they patched this already, because it would be the next thing to actually get working. Anyway, amazing stuff. I'm thrilled. I'm happy that stuff builds and that we are one step closer to one fix closer to release our next set of amazing, even higher performance ISOs, because we also switched to the ELF version 2 ABI for even slightly higher performance. I hope you enjoyed this, learned something, especially all the other in-depth stuff, compiler support things, what compiler do, what general methods for improving code density, and that including learning that PowerPC is still a thing in banking, financing space, data centers, and so on. The bunch of top 500 that run PowerPC architectures, looking Summit, Oak Ridge Labs, lived with the idea that IBM ditched PowerPC. No, they didn't. However, Oracle ditched Sun's Spark. Unfortunately, doesn't stop us from still loving and developing for our precious Sun Ultra Spark systems. Yeah, amazing. We did our thing. I need to move on. Don't forget to share, subscribe, and I hope to see you soon for all the next fixes and improvements to